15 minutes, and 10 minutes in, I will give you the heads up. And the audience, please feel free to ask questions. Good luck.
Okay. Yep. Thank you for the introduction, Kausha. And I'm Shun Sakaida from Murata Manufacturing Companies, entitled with a highly conductive MXene for electronics. We are very glad to have this opportunity to talk with you using the very good platform, the TechBricks. We give a brief introduction for our companies, the Murata Manufacturing. We are offering the electrical components in the to make our life better using the electronics. Our main product is the capacitors. Is the multi-layer ceramics. The capacitors MLCC is the recently more and more number of the capacitor is required for revolutionary electrifications. Everything is required. Everything is needs the electronics made of. And in the automotive applications, in the 5,000 or 8,000 number of the MLCC was used. And also, we are fabricating the EMI, the ESD components. And if you have a smartphone or some tablet, there are maybe you use 4G mobile communications, LTE networks is required using the SOW surface acoustic wave components to make a noise cut down the noise for better communication, mobile communications. So we are using we are fabricating these components made of the inorganic ceramic materials. So every time we turn the inorganic materials into the product. So we are still looking for state-of-the-art inorganic material, ceramics, into the new product. So we are excited to what kind of the product will come out from the new materials. Then we are paying attention to the the very famous the MXene's inorganic materials is the last decade there are many people paying attention to this one of the two-dimensional materials field. This is just a brief introduction for the MXene in the synthesis procedure. Is from in the example the Ti3C2 is the Ti3 aluminum C2. This is a precursor material. So it is fabricating, mixing and sintering and grinding the conventional ceramic synthesis. And then we the aluminum element is removed out by chemical etchings using an HF and HCl procedure. So you obtain this kind of the accordion-like the two-dimensional crystal structures. Then using the Cassian delaminations, you obtain the monolayer of this kind of two-dimensional exploited seat in the Ti3C2, the MXene we call. And this state-of-the-art material has several characteristics. Is of course you see the two-dimensional, and it's very good metallic conductivity is as high as 18,000 Gms per centimeter, and also is very similar hydrophilic. Is easy to well dispersed in the water, so it's the eco-friendly material. Is not use the organic solvent. But one of the challenges in the MXene, especially for applications in electronics, is some environmental stability to humid conditions, because yes, this material is hydrophilic, so easy to the water is coming in between the layers, and some water molecule is makes this lattice expanded. So is in the out of plane directions, there are some conductive pathway is disturbed by